Welcome everyone to this session on DevOps on the AWS cloud. Let's first understand the DevOps term. I think you are all familiar with the AWS public cloud. AWS, Amazon Web Services, is the industry leader in the public cloud computing area for the last 6.5 years, 7 years. We are in the top quadrant of the Gartner Magic Quadrant. So in next 1 hour, we are going to share what AWS platform has to offer to enable our customers and partners start using the DevOps services. We will also be going into one of the customer case study where one of the AWS existing customer has used these services to solve their business problem, and we'll go into that details later on. So just to introduce myself and some of my colleagues here, my name is Sanjay Nigochkar. I'm the Senior Solutions Architect at AWS. And I'm joined here with my other colleagues, Pavel, who is the CTO of ClearScale. ClearScale is AWS partner, and they help enable customers to adopt AWS cloud using best practices of design, delivery, and implementation and support methodology. I'm also joined by Jimmy Chu, who is the solution architect at ClearScale. And he's going to cover in lot detail the use of Docker container service and how to use the existing AWS DevOps services to enable and build the best practices architecture and design. And finally, Jeff Hobbs, who is our customer, and he's the Director of Web and Geographic Systems at San Jose Water Company. And I think it will be very interesting to know their use case and share their experience in terms of adopting the DevOps practices. So let's see, first of all, let's understand why exactly we are here. Understand the DevOps definition first, because it's relatively a new terminology. It's been there for the last 3+ years. And before DevOps, there were two areas where the traditional IT organizations were creating or carving out their teams in terms of the development team, and they have a separate operations team. Now those roles and those skill set have kind of merged together, and there is very thin line between what developers are doing today in the cloud computing world and what operations teams is doing. So DevOps is nothing but it's a culture, it's a movement, or it's a practice, and really it emphasizes the collaboration and communication of the both software developers and the other information technology professional, while they are automating the process of software delivery and infrastructure changes. So if you see that in any IT organizations where there is an initiative to automate the software services delivery activities for development, QA, and operations, then that combined framework falls under the DevOps. So it's a DevOps is not just one area or one team or one tool set. It's an ongoing methodology that, again, the customer adopts them based on their needs. So before we begin, really, I want to really emphasize on why we are here to talk about DevOps and why it is more relevant than before. Well, we all know that traditional IT, which is what we call the IT 1.0, and its services of managing the practices, they both are becoming obsolete, right? So that's what we call traditional development models are obsolete. We know that business is getting more and more competitive, more and more software driven. Business want the feature the next day. They don't want to wait for IT organizations to provision the infrastructure, give them a week and month to get the right infrastructure for their needs. And we hear these terms commonly that even the infrastructure has become more and more software defined. You might have heard the terms like software defined storage, software defined networks, and so on. So companies and IT organizations, they don't want to manage hardware. The sprawling of SaaS also and its ease of use, that is also making the business grow relatively faster. So definitely the business drivers are there to make the provisioning process very fast. End users expect both continuous improvement and stability in the application. Now there is a more and more demand for greater stability, high availability, and stable environment. Yet the users are really demanding greater features and faster services delivery turnaround time. So that's kind of a big challenge in front of the IT organizations to how to speed up that delivery. Right. And of course, IT needs to be able to provision infrastructure as rapidly as the developer demands. And that's really in the cloud computing world, we all know that it's a click of a button and you get the server provision in the desired cloud uh, platform. So it becomes really IT organization job to provide those SLAs and provision the infrastructure rapidly than before, just to meet the customer business objectives. And finally, an organization's pace of innovation. So innovation is really the key word here, because innovation is driving pretty much every aspect of the growth in the SMAC area. When I say SMAC, S-M-A-C, it's social, mobile, analytics, and cloud. These four domains are taking on the next generation of IT organizations. And companies are, and the CIOs and the IT leadership team, they are constantly evolving to around these areas. And AWS is here to help you. We have 50 plus services, uh, broad range of infrastructure, DevOps services, network, identity and access management services to help you enable those and then get to those business objectives as fast as possible. Now, DevOps, how it can help? I think most importantly, as I said, DevOps is a continuous process. The DevOps practice, once you adopt in your IT organization, it really helps companies to innovate really at a higher velocity. Now, what it increases? Really, it increases the business agility. Now, the business is getting their feature requests developed very quickly. They have now ability to reach to the untapped market segment pretty fast compared to in the past. Also, the application has become more and more stable. So the stability is the key aspect. Now you have the infinite compute and storage available at your fingertips, which you can provision to make the application more stable. You have geographical regions available to deploy your applications and bring that higher level of stability SLA to your customers. It also meets the customer demand. So customer demand, and that really varies based on the industry to industry. And really it for small medium business like startup companies, the demand to meet the customer requirements are really exponentially growing on a day-to-day basis. For enterprise customer, really the customers which are nothing but internal business units, they are asking for more rapid deployments. And really the time to spend on innovation, that is increasing as well. With these infrastructure at your fingertips, the developers are now becoming more and more innovative. They are spending less and less time on environment provisioning, environment stability, code deployment, and things like that. So now they have an area where they can really think out of the box, automate the process, and really meet some of their day-to-day operational challenges. Finally, the security. Definitely the security best practices, once you implement in the proper order, the overall environment and customer experience becomes more security friendly. And we have a lot of security best practices on Amazon website, which can help you how to secure your application and infrastructure and data in the public cloud environment. Now, what DevOps can decrease really is all the pitfalls from the IT 1.0 world, where the length of deployment cycle was too long, monthly release cycles, quarterly release cycles, so that has been shortened. Now more and more agile development is happening. Time to market has been decreased. Now business is releasing those features based on the demand, and so their time to reach to those customers is greatly decreased. And they have then competitive advantage over their competitors. Finally, the deployment failures and rollbacks. So now you have an automated deployment build process. So there are very less chances for human errors or deployment failures of any sort. Time to recover upon failure. So now you have the fault tolerant and highly available infrastructure at your fingertips that you have designed while going into the cloud computing world. There is very less time, or there is very quick. It is very quick to recover those failures from those failures. And finally, the operational overhead has been decreased. So you are now talking about the operational cost has gone down. Every CIO want to spend less and less on operational aspect. They want to have most of their IT organization and their professionals' time to be spent on the innovative and new application or new feature development work. So how AWS is enabling the DevOps area? So AWS is in the DevOps area for last 3+ years, and we have various services which you might have heard. Some of them are code deploy, code commit, ops work, cloud formation, beanstalk, and so on and so forth, which an application development professional can use based on their needs and in different order. So what AWS is really, they are providing on-demand infrastructure resources, and really a lot of those tools, if along with our partnership with many of the technology partners and our consulting partner, they have a lot of tools and services to offer, really to enable the common DevOps practices. And they are kind of segregated into the 4 broad areas. So infrastructure as a code, obviously, so that's a new concept coming up. The infrastructure is not anymore a hardware. It is treated like a code, so the developers can manage their own infrastructure at their based on their needs. Microservice. Microservice is nothing but the whole breaking up of the environment, application environment, from top to bottom stack into different small services. It's like a Lego block, and you connect those services in order for them to work really seamlessly in an orchestrated manner. Logging and monitoring is the key aspect. Every activity that your end user or your developer or your administrator is doing, we can log and we can monitor on a real-time basis and take proactive actions. And finally, the continuous integration and continuous delivery. I think this is the main important aspect of the DevOps area, where constantly the developers are developing, they are integrating various modules, and they are constantly deploying. So it's like a pipeline. And we'll look into all of these 4 areas in greater detail. So what is infrastructure as a code? So really it replaces the traditional infrastructure, which we used to host it into our traditional data center. We used to manage it. There used to be a process to procure that hardware through the BOM, through the specification, getting the invoice done, and all that. Now all that traditional infrastructure provisioning and management, it has really come to a point where the IT organization don't have to worry about procurement and setting up rack and stack and so on. So really it's a as soon as it becomes code and as a virtual appliance that you can provision through a web interface, then you are really talking about provisioning of the server, storage, network, any aspect of your stack. You are really deploying independently. You have your own segregated area as a single service or group of services, right? You are also making those configuration changes repeatable and standardized. So now this is where the first step towards the automation. Once you know that what are my repeatable tasks, I can probably look into making those automated using our cloud formation template or any other third-party tool, which will go into more detail in subsequent slides. We are also looking at building the custom templates to provision the resources, and this is where the cloud formation is very powerful service from AWS, which can help you really control that environment. You don't have to build a new landscape or the environments from scratch. You have one environment, you can create it as a template, and then you can have that cookie cutter or a templatized process to create other similar environments. You also use version control to keep track of all the changes. And this is a very powerful key feature of the infrastructure as a code, where really you have the full control of which changes to go into production at what point in time. Microservice, you are now building really the application as a set of small services, and they are all communicating with each other through API. And the API based model is really powerful, and it has picked up heat really for last 7 or 8 years. Before that, it was all point-to-point connectivity. It was all based on, let's say, data flow from one publisher to subscriber in your traditional message bus kind of architecture. You are doing programmatically, you are integrating 2 segregated environments, and that was all very painful and time-consuming integration. Now with the standardization of JSON, RESTful API, XML kind of standards, you are now talking about really seamlessly merging multiple services into one cohesive orchestrated environment. So really you are building the services around business capabilities, right? So you are not really looking into how many servers we need, what type of data it flows from point A to point B, and so on and so forth. You are scaling up and down as required, right? with virtually no notice because you have infinite compute at your fingertips. Make the configuration code changes repeatable, and this is where it is again important that you are applying those configuration changes as you are moving along in your delivery cycle. The API driven model also enables management of infrastructure and language. This is where most of it is typically used in the application code. So writing the API handshake takes less time, and you are really enabling all the management aspect into the application code itself, instead of asking for sysadmins to help you do some of the low level configuration changes on the environment. Now it also frees the developer's time from manually configuring the operating system, system applications, and so on. So now really we are talking about merging the sysadmin, network admin, storage admin role with the developers, and they all become one entity, and that's what we call the new role called DevOps engineers. So really understanding the microservice and API is the key aspect, and we have a lot of documentation available on AWS website. Each and every service on AWS platform is API enabled, which you can use based on your needs. Finally, the logging and monitoring. So logging and monitoring process involves capturing, categorizing, and analyzing the data and the logs. So you want to keep track of all the events, all the activities from the users in your environment so that you have a better understanding of their behavior, their patterns, and also you can detect the failures or the errors in the application and take proactive action. So you are really maintaining that visibility and adaptability, auditability rather, in all the activities. We have a service called CloudWatch, and that helps you monitor the performance of the application on a real-time basis. You can really create nice dashboards and watch all the events that are happening. We have another service called CloudTrail, which keeps track of all the API activity that the user is doing. So finally, I think in this logging and monitoring, we also have, you can assess how applications and environment, infrastructure performance, it really impacts the end user experience, and accordingly you can take actions to add the capacity into the environment on the fly using AutoScale. You can also gain insight into the root cause of the problems and really what different changes are happening in the environment. You can support various services and which are really required for 24/7 kind of SLA as a result of this continuous integration. So now, literally, there is nothing, no concept of let's say the severity 1, severity 2 application. Or priority 1, priority 2 application. It all becomes priority 1, and you can even have your development environment as priority 1 theoretically, just because you have continuous integration and continuous delivery happening with AutoScale environment underneath. And you are creating alerts based on the threshold, so you can always set alert me when my CPU utilization on a particular server is 90% or more, and the system will let you know and take appropriate action. You can even automate that to automatically add another server in the pool based on these thresholds. And Jimmy will cover those aspects into his technical deep dive. Finally, the continuous integration and continuous delivery. As I said, this is the core concept of the DevOps, and this is really to enable the developers constantly work on the new builds, test them out, deploy those, and really decrease the time to market. So you are releasing those features pretty fast, and hence the business is getting competitive advantage over their competitors. So it really improves also, it reduces a lot of human errors of deployment. This is really the model, and it really helps you to kind of do your custom release workflows. You may choose to have one workflow of code delivery and deployment for one customer or one of your business unit than to the other, depending on their needs. You can also are automating the deployments of the new code, so you are not really running those in WebLogic. I remember we used to have the build.sh and all those commands, so you're not doing anything on the command line anymore. It's all API driven, it's all console driven. You are also improving the developers' productivity and really delivering the updates faster. Finally, the address bugs. I think this is important aspect because now you in the pipeline of the delivery pipeline, you have complete visibility into what's happening and where the bottlenecks are in terms of the bugs or the runtime errors, and you are taking really the proactive action through the testing cycles. And finally, they store anything from the source code to binary into the existing Git code. So we'll look into how there are various configuration management services available. One of them is GitHub, which is pretty popular. You can use CVS, SCCS, or any other third-party configuration tool to store various versions of your source code. And obviously you can create a cycle to merge various changes, and this is all happening automatically through the CI/CD, which is continuous integration and continuous delivery services. Finally, the benefits of using the DevOps on AWS. I think, as I said, you are automating the system operations. You're starting quickly based on the pay-as-you-go, so you are not really over-provisioning. You are not worried about over-provisioning of the infrastructure. You are only consuming what you really need. You have full visibility into all the aspects of your environment. You are also leveraging the managed services and the various aspects of the management, orchestration, and automation tools available. You are scaling without the infrastructure constraints, so you are not depending on the system administrator or IT organization. And I'll go very quickly here. So these are the various services, and you can read through this. As I mentioned, code commit, code pipeline, ops work, and cloud formation. These are the core services that AWS has, and we have various partners or tools and technology partners who have their products available in these areas. This is the software development lifecycle. As I said, DevOps is a lifecycle, and which service of AWS falls at what stage. So during the coding, you are really doing the code commit. Developers are committing their changes into using the code commit service, and code pipeline is where you are really building and testing that environment and so on. So I will highly encourage you to check out our AWS documentation on various DevOps services. And finally, the tools which are available. So we have Elastic Beanstalk, Ops Work, and Jimmy will cover this in more detail. You can either have higher level services for convenience. For smaller applications, you can directly use Beanstalk. But if you want to do it yourself, then you can. This requires a little bit of extra additional skill set. Cloud formation is the way to go, and along with that, use some of these services to really manage your own environment on your own policies and practices. So with that, I'm going to hand over to Pavel, who will talk about the continuous integration with Docker on AWS. Pavel?
Yeah, thanks, Sanjay. So, yeah, my name is Pavel Pragin. I'm the CTO at ClearScale. So before Jimmy takes over and starts talking specifically about San Jose Water Company and what they did on AWS and how we helped them, I wanted to give you a quick background on ClearScale. As you can tell, there's a lot of services that AWS has, and sometimes to get going, some companies need help. So they usually come to a consulting partner to get that help. So ClearScale is a AWS consulting partner. We've been around for about 6 years. We're a premier consulting partner, which is a very small group of about 25 partners in the US. And we're very focused on AWS and helping AWS customers. We have 5 competencies from AWS. So these are sort of like audits that AWS puts you through. So we have a migration competency, we have a big data competency, DevOps competency, which is really applicable to this webinar, as well as marketing and mobile competency. And our team is rather large, and we have many certifications, professional, associate, and we have a lot of skills in DevOps area and actually in many different areas of AWS. And we're based in San Francisco. So just a little bit more here before I hand it over to Jimmy. I wanted to go over some of the services that we provide in case anybody needs them at some point. So architecture design is where we come in and help gather requirements and understand your needs and help you design your system on Amazon. And this includes DevOps, of course, end-to-end. Integration and migration is where we come in and help migrate workloads to AWS, which is very common. And of course, whenever we migrate, we also automate in the process. We never migrate kind of one-to-one. We very much focus on automation of infrastructure. And of course, DevOps automation is the third tier of services that we provide. So this is, helping customers with CloudFormation, helping them with OpsWorks, helping them with Docker and ECS, and any kind of custom automation that they may need end-to-end, all the way from infrastructure automation to continuous integration and so on. Of course, there's big data, ingesting, processing, storing, and streaming big data, deploying business analytics tools, and helping customers gather, process, and view their data in different ways. Also, we provide application development capabilities. So we do mobile, backend, and front-end development, and any kind of development around Amazon that you may need. And the last piece is managed services. 24/7, 365 monitoring, remediation, and management, for companies that don't have a large staff or just don't want to deal with this 24/7 on-call kind of rotation. And of course, we've been doing this for 6 years. We have a lot of customers, a lot of success stories, working with large companies like Samsung and Aetna and Shinola, GoPro, EMC, and many others, as well as many startups in the Bay Area. And startups have always been our focus. So I'm sure some of you guys are working for startups, and if you need help, please reach out to us. So I think at this point I will hand this over to Jimmy, and he can talk about San Jose Water Company and some real interesting technical details.
Hi guys, this is Jimmy Chu, and I'm going to just cover at a high level some stuff about Docker, application portability, continuous integration delivery, and some of the business impact. And then we'll hop into the case study of San Jose Water Company. So let me start off with a definition. I pulled this right off the Docker website. Docker is an open platform for developers and sysadmins to build, ship, and run distributed applications. So what does that really mean? So let me hop over here. We've probably heard of the term application portability. So really, in a nutshell, what that gives us is ready-to-run software. It's like it's like the plug-and-play of 15 years ago, right? Something that you can take and in any operating system plug it in and it's off and running, kind of like USB of today. What allows you to run this piece of software with all its libraries, everything, anywhere, whether it's on your laptop, a desktop, in a public cloud, a private cloud, it will run the same in all those platforms. And what this really allows us to do is really share those microservices, whether it's between developers, between development and QA teams, operation teams. It makes that really, really easy. You no longer have to also send instructions on how to configure the operating system and underlying services. You just simply say, here's the app, go instantiate it and get running. Then continuous delivery. And I'm not going to talk specifically about continuous delivery, but how does Docker or microservices impact continuous delivery, right? So we're going to say goodbye to software conflicts, driver compatibility issues, and library conflicts. So like I said before, right, this is one package, it runs anywhere. You no longer have to also integrate those system-side instructions on how to configure operating system and so forth as part of your release process. Now it's just with Docker, we really just care about here's the application, we're releasing it. This decouples those dependencies between the development and the true infrastructure operations and puts that power into the developers or the DevOps process. Let me hop through. And then business impact. Now this is coming from kind of a ClearScale perspective of things that, I did not see blatantly listed online as, hey, did you think about this? So for companies that are building software, right, this is your product, you're offering this to your customers, the use of microservices and using Docker containers can actually help you reach new customer segments. So we've come across instances where our clients' customers say, well, we love your product, but it needs to run in my private cloud or in my public cloud or on-prem for me. It can't be hosted outside of my infrastructure. And so this methodology of using microservices and using Docker really streamlines this effort so that irrespective of what's underlying, as long as they can run a container, then you can hand them over this ready-to-run application. And as far as software upgrades or updates go, you no longer have to send this huge, giant list of how to upgrade that software. You simply hand them a new image. Here you go. Here's the newer version. Why don't you instantiate that, and now you're up and running again. So this reduces operational costs not only for your company, but your customers as well. So that's kind of a win-win kind of situation. And then also what we've seen is sales folks are able to go in and do demos and POCs within a customer's environment without this long trail of, okay, well, now we got to get the customer to set up the operating system, and here's, again, here's a deployment list of how to get our dependencies up. It's really, if you're running containers, great. Here's our image. Let's get it up and running. Let's do a demo in your environment. And then, of course, faster time to market for new products and features. That's kind of across the board for continuous integration. And so, deploying and managing Docker containers on AWS, it really, AWS has really simplified this, right? So we look at where's our code, whether it's code commit, GitHub, something of that nature, and then where are we going to store these Docker images, whether it's Docker Hub or EC2 container registry, and then how are we going to orchestrate this process? So we look to code pipeline, or a lot of people are familiar with Jenkins. And then the simplest way to actually manage the containers, Elastic Beanstalk and EC2 Container Service. So let's take a look at a general principle for getting this going, right? So there needs to be an integration between your code repository and whatever your CI/CD toolset is going to be, whether it's Jenkins or code pipeline. That CI/CD toolset needs the ability to create Docker image and upload that to your container registry, whether Docker Hub or EC2 Container Registry. And then as part of your CI/CD workflow, you'll create an Elastic Beanstalk application. And this is just the configuration for it. And you drop that into S3, and then you connect to Elastic Beanstalk and say, all right, here's the Docker image, here's your application configuration, let's launch the container service. And it will handle the ECS portion, getting the application installed, handling your auto-scaling features, and configuring your ELB. And then as an add-on to that, let's launch some automated tests, and then rinse and repeat this for each environment you're stepping through, right? Development, QA, staging, production. They're the common ones. And then now I'll introduce Jeff to talk a little bit about San Jose Water Company.
Thanks, Jimmy. My name is Jeff Hobbs. I work with San Jose Water Company. We were founded in 1866, and we serve about 1 million customers in the greater San Jose, California metropolitan area. We've got about 36,000 uniques a month coming to our site. Our challenge and why we reached out to ClearScale is that we had a lot of challenges trying to release a new code or update existing code in our Rackspace environment. When we had to do that, we We had to typically promote and demote servers, work with our load balancer, and inevitably this led to large gaps between releases, weeks if not even months. And as importantly, it took us about an hour or so if we had to fail over to a secondary region in case we had an outage in the primary region. And so our goal when we contacted ClearScale was faster delivery of new application features and functionality to the customers with minimal IT overhead and maintenance costs. And as we talked to ClearScale, we identified the requirements. We really wanted to fully automate this process of release. Anytime we wanted to have a new code base deployed, we wanted to be able to push a button and have zero downtime, and that was really key in our process. We also wanted to integrate it with current technologies we use internally. So that includes Jenkins for continuous integration, and we also wanted to integrate with GitHub, which we use for all internal deployments as well. And as importantly, we also wanted to have our failover to a secondary region be lowered to a minute or two as opposed to an hour plus. And those were all key requirements we handed over to ClearScale. We talked to Pavel, and they came up with a solution. And I'll hand it back over to Jimmy now to talk more about the solution.
Great. Thanks, Jeff. And so let me just walk through the ClearScale solution. So, we leveraged 3 of our services: architecture, design, integration, migrations, and our DevOps and automation practices. And so what we did was we designed and implemented an AWS native solution, right? It's optimized to deliver maximum return on investment and take advantage of all the key features we always hear about as buzzwords around AWS. And we fully migrated completely to this new technology stack. Right? Before it was on-prem physical servers, operating systems, pretty traditional stack. And then the deployment process, after we created this technology stack, we wrapped it with the CI/CD workflows, right? Jenkins, Amazon Simple Notification Service, some AWS Lambda, and of course Elastic Beanstalk. So let me just let's get to the next slide. Just real briefly, the architecture design, right? We took advantage of AWS. We created multiple availability zones. We have services redundant in both zones. Taking advantage of RDS, we're taking advantage of Elastic Beanstalk to manage these applications, and of course Elastic Load Balancing for the applications across the 2 zones. And again, Jeff had mentioned that we took their existing GitHub and Jenkins and we integrated that into this design. Everything else is native AWS services. Let's go to the next slide. So let's talk a little bit about the DevOps and automation portion of this. Now, of course, this is some implementation principles from ClearScale. This is how we generally think about things. Not every project lands into this particular mold, but this is kind of a general guideline. We like to use CloudFormation to deploy and manage the base infrastructure components. And when I talk about that, I mean creating VPCs, creating the subnets, attaching the internet gateway, configuring routing tables, creating security groups, VPN gateways, basic networking infrastructure components like that. And then with Elastic Beanstalk, this is the heavy hitter, right? Elastic Beanstalk we're using to create ECS clusters, deploy Tomcat and PHP applications as Docker containers onto ECS, configuring auto-scaling across those services, and then attaching those applications to ELBs. And then all of this process in the background managed again or orchestrated by Jenkins. And then this is a slightly more advanced version of kind of the baseline that I showed you earlier. So the CI flows that we created, we added some services, simple notification service, some Lambda service to automatically trigger builds when things are checked in from GitHub. Now the core differences here versus that more simplistic model is we're also making some changes in Route 53. We're also taking a production database and restoring it into, in this case, the staging environment, and then launching our tests and being able to fully test that all the applications with the correct database before we move on. And that's very, very powerful to have this happen and kick off automatically. Okay. And then implementation and migrations. So again, we start with infrastructure as code. We talked about this earlier in the presentation, but when we code those CloudFormation templates, we not only use those for the initial deployment, but ongoing management of those networking components as well. If we make a change to a subnet, add a route, we do that in the CloudFormation template, and we're able to populate those changes into dev, into QA, into staging, into production, exactly as we release the application code or the containerized services. So now we have a solid methodology of releasing that entire infrastructure plus application together. And then, so again, we created the infrastructure and we did extensive testing in the staging environment to ensure that we have stability, we have scalability of the components, all of the AWS services are functioning as we desired. And then once we were completely satisfied there, we got a sign off in staging. Deploying to production was like a walk in the park, right? With all of the DevOps automation that's created, we deployed the production environment and then give a final test there, and then we wrap the CI/CD workflows. Right? Now that we have the working environments, we can actually go into testing that the workflows are promoting code and configuration and making our database changes correctly. Okay, and then we moved on to data synchronization, and just so everybody knows, at the same time, the traditional stack is still running. The old infrastructure was still up and running. The code is being developed and checked into GitHub just as it always has. This is a completely parallel process that's being able to deliver code to a completely new technology stack. And so when we're approaching that time, looking into migration, it's all about data synchronization, get all the user-based data and the database migrated in. We perform a mock cutover. So everything minus that last DNS switch, right? Tested extensively. We got, our T's are crossed, our I's are dotted, and then we went forward and were able to pull off a seamless migration for that infrastructure. And then maybe we can get Jeff back on to talk about some of the benefits that they were received.
As a whole, it's been a great win for us. We've been able to really come at the point where we're pushing a button and being able to do a full deploy. It's on demand, and so we push the deployment button, and it takes about 15-20 minutes, and it'll create a new staging environment, which allows us then to test in our environment, Then when we're ready to push, we just cut it over, and it leads to really zero downtime, much faster response times as well, and also great failover. And so we had a failover once for testing, and it was a minute or so at the most, which was great. A vast improvement over what we had in the rack space, more flattened environment. So then great benefit also on the RDS side. So we had in an old environment, we had just MySQL and Postgres running in just flat VMs, and that took a lot more backups and things of that nature, whereas having it in the RDS environment, backups are free, managed, etc. Overall, just a great win for us, much easier to deploy, and overall, a great success for us.
Yeah, and I also like to just say that applaud Jeff for being courageous enough to not only migrate over, but to completely redesign the infrastructure. It's really took advantage of that opportunity. And I believe that kicks us into the Q&A portion of the webinar.
Thanks, Jerry. Thanks, Jeff. So we have been getting some Q&A, and thanks for posting your questions early on. I've been trying to reply those as they come in. There are a few questions that we would like to cover, which really are commonly asked by many of you. So let me quickly go through. So first of all, yes, we will share this PowerPoint towards the end of this, and we'll make sure that you all get a copy of this this presentation. Let's see. We also have a question. It says, I have heard the Docker being used for development and QA, and is container technology used for production environment? Is Docker ready for production? Jimmy, Powell, do you want to take this?
Sure. Hey, this is Jimmy. So we've definitely heard those concerns in the past when Docker was just coming out and people were testing it in their development and QA spaces and really having a blast. And I think the key concern there really wasn't the stability. It was more of the manageability and the ability to log and understand what's happening in a containerized application, since it's not tied to an operating system. And so, but there's been a lot of advances in the container engines where they're capturing all logging. We've got a lot of clients, sending those logs into CloudWatch logs. We have clients that are creating, elk stacks to gather that data. So it's definitely proven to be production grade at this point.
Yeah, and this is Pavel. I wanted to add to that. So especially over the last year, we have seen a very large increase in adoption of Docker in production. We have customers that are using it right now in production, and not just startups, but actually enterprises, like even in financial technology and other regulated industries, as well as just very large enterprise companies. So it's definitely being used in production, and it's being adopted very rapidly across the board.
Thanks, Powell and Jimmy. And there is one more question, Jimmy, that I have sent it across to you. If you can answer, that's in detail. But in general, I think one of the things I want to highlight on the previous question was the Docker and Amazon. They are close partners, and one of the ECS, the EC2 container service is fully to enable the Docker implementation and make that experience very easy. So I would highly encourage you to look at some of the AWS existing documentation and some of the use cases and best practices how to use Docker in AWS. It is production ready. 2 years ago they announced it into the DockerCon in San Francisco, and people have started using it in the production environment. Okay. We have also a next question. I think the Docker implementation in real time. So one of the attendee asked if we can show the Docker implementation in real time. Unfortunately, in the 1 hour we could not cover that. I would encourage you, there are some presentations available on AWS site which you can see. Yes, there are some YouTubes available from the previous reInvent events that in the past, where we demonstrated during the presentation and sessions the live deployment of or setting up of the Docker environment on AWS. So you can easily find those onto the YouTube by looking at some past reInvent sessions. There is one more question. One of the attendee asked, how would an organization shift to using Docker? Can we deploy Docker and regular servers in parallel during this transition? Jimmy, again, you want to take this?
Absolutely, and I think in this case, we did just that with San Jose Water Company. So I was mentioning before that they continued business as usual, deploying to their traditional infrastructure in that architecture. And what we built was something completely in parallel. The only integration point there was at GitHub. So we were leveraging the same code base going out to the traditional versus this new architecture.
Great. Thanks, Jimmy. There is another question. Does my development team need to recode the application in order to use Docker? And I think that's a great question because Docker is fairly new and it is unclear as to what language it uses. So again, I would refer back to Jimmy if you can highlight this.
And so I think in this space there will be a little bit a slight bit of change initially, not to the actual code base that developers are writing, but that initial creation of the Docker image, we kind of need to think about what are all the libraries associated with this application, right? What are all of the dependencies that the application needs to run, and then getting that into a Docker image, and then automatically build it from that point forward. So initially, there will be a little bit of investigation and development in that kind of DevOps type space.
Great, thanks, Jimmy. We have 2 more questions, and I would again encourage you, we still have 3 minutes to take on the Q&A. Please post your questions on the Q&A area. The next question is, what is the ClearScale's process for projects involving complex migrations with DevOps and more? Pavel?
Yeah, sure, this is Pavel. So yeah, I mean, we have a pretty defined methodology for running most projects, and usually it's a phased approach depending on the size of the project, but it usually starts with requirements gathering, then we get into architecture design. After we're done with architecture design, we get into development of the DevOps components. Then we move into deployment of the different environments. Usually there's production, staging, QA, UAT, whatever the customer needs. And then we get into if there's a migration involved, then we do a data migration. And if it's a brand new application, we move straight into testing, functionality testing, as well as load testing sometimes. And then we go live, and after that we do documentation and training and things like that.
Great. Thanks, Pavel. I have one more question, maybe related. What are the differences between managing AWS versus on-prem environments? And does ClearScale offer managed services to help maintain those new generation Docker-based or DevOps-based platform?
So I think because these technologies are all still fairly new, the adoption is high, but unfortunately the skill set on the market is still not as good as we want it to be. So the learning curve is big, especially for people who've been working in a traditional enterprise environment for a long time. So it's always good to get the help of a partner while your team is getting on board and learning and working with us to understand how to operate the environment and how to build it and so on. So managed services can be helpful sometimes to provide that 24/7, 365 type of support that you need to bring your team up to speed and to maintain these new technologies. I mean, obviously, also you can work with, and you do work with AWS support. So between AWS support and ClearScale managed services, you can be in a very good position to successfully adopt and manage and kind of maintain all these different new technologies.
Great. The next question is for Jeff. This is very specific to your use case. What is the cost difference for San Jose Water Company between the Rackspace and AWS? And again, this is the cost level, the on-prem versus public cloud.
So I don't think we know an exact cost. So far it's been about equal. We actually were using a few different AWS services already, and even when we were on Rackspace, we were using Route 53 and S3. So I think right now the costs are fairly equal. We just actually went into a reserved instance for a year, which will lower those costs by, I believe it was right around $800 over the year. So we're getting a lot more, for that dollar though. So I think for us it wasn't so much the cost as it was, the return on investment for that dollar. And so it's, a hugely different environment and much more of what we need for an IT team our size.
Great.
Yeah, and this is Pavel. Let me add something to that. And I think that makes a lot of sense. I think, San Jose Water Company was already using a virtualized environment on Rackspace. Other customers that we have seen moving from Rackspace traditional physical servers, we have seen a pretty dramatic cost savings in that case, up to like 30% in some situations, because they no longer had to have physical load balancers, routers, switches, and a whole bunch of hardware to manage and maintain.
Great. So we have 2 more minutes and we have some additional question. Very quickly, let's try to cover as much as possible. So what is typically the timeline for migrating from the traditional deployment on-prem into this Docker-based or DevOps-based framework? Pavel or Jimmy?
That's a pretty interesting question. I think some of the challenges there are the complexity of the current application. Right? Obviously, if your application is composed of 50 services versus 10 services, there's a large gap in that ability to deploy all the services, and depending on how much data you have, right? The larger the database, the more time we need for actual migrations and data syncing and so on. And then also based on your requirements. Some clients will have regulatory compliance that they need to think about too. So it really depends project to project. I mean, maybe Jeff can give you an idea of how long it took us to complete this for San Jose Water Company.
Gosh, it's been a while now. I mean, I think it was off and on about 2 months. And then there was some testing involved for sure, but it wasn't a long time. Yeah, but I think it was probably 1.5 to 2 months was the overall scope.
Yeah. So, but I wouldn't expect folks to be able to pull off timeframes like that on their own with their day job as well.
Okay. Great. Thank you so much, guys. This is great, and thank you for attending today's webinar. I hope you enjoyed the content. We will make the contents available after the webinar. Jerry, any final words?
Appreciate everybody.